Okay. So yesterday we started right at the very end of class, simplifying using trigonometric identities. My hint for you is most of the time I want to try to write everything in terms of sine and cosine. And I really like to get rid of addition and subtraction if possible. So I want to look at the middle one here. How could I rewrite cotangent in terms of sine and cosine? How could I rewrite cotangent in terms of sine and cosine? You might need to go back and look at your identities. We've talked about Pythagorean identities. We've talked about reciprocal identities. We've talked about tangent and cotangent identities. Yesterday, we wrote down this guy as our tangent identity. So think about what you know about tangent and cotangent. How could I rewrite cotangent in terms of sine and cosine? Cosine over sine, yes. So I can rewrite cotangent as cosine theta over sine theta, right? So I'm going to bring that down right here. Cosine theta over sine theta. How could I rewrite cosecant theta? Think about your reciprocal identities. How could I rewrite cosecant theta? One over sine theta, yes. I've got this horrible to look at compound fraction. I really don't want it to be a compound fraction anymore. So cosine theta over sine theta. What could I do with this denominator so that I didn't have a fraction in the denominator? How can I get away from dividing by a fraction?
Multiply by the reciprocal.
Yes. We're going to multiply by the reciprocal. So the reciprocal would be what?
Sine of theta over 1.
Sine of theta over 1. How can I simplify this?
Both of the sines of theta cancel out, so it would just be cosine of theta.
Yes, my sine thetas are going to cancel out. That would give me cosine theta over 1, which is going to simplify to just cosine theta. Beautiful. All right, let's try another one. Secant x, cotangent x minus sine x. First thing I want to address, and we didn't really talk about it yesterday much, they're using x as the angle instead of theta. That's okay. It doesn't matter what I call my angle, as long as it stays consistent with all my trig functions. So let's try rewriting these in terms of sine and cosine. How could I rewrite secant? How could I rewrite secant? Think about your reciprocals. One over cosine. So this would become 1 over cosine x. That is being multiplied to my cotangent here. How can I rewrite cotangent in terms of sine and cosine?
Cosine x over sine x.
Yes, cosine x over sine x. And then minus sine x, that's already in terms of sine and cosine. Can I simplify anything here?
The 2 cosine x cancel.
Yes. My cosine x's are going to cancel. And so I would have 1 over sine x minus sine x. Is there anything that I could do to be able to combine these two things together? Can I actually subtract them?
Could you repeat that? I couldn't hear you.
Yeah. Is there some way that I could combine these two things together? I have a fraction and then I have something that's not a fraction. Can I subtract these two things?
Well, they don't have common denominators now, so you would have to make it a common denominator.
Yes, I would have to give it a common denominator. So right now it would be over 1. What should my common denominator be?
Sine of x.
Sine of x. So I'm going to multiply top and bottom by sine of x so that I can give it a common denominator. All right, so I would have 1 over sine x minus sine x times sine x would be what?
Sine x squared.
Yes. And we write that as sine squared and then the x. That right there means the same thing as sine x squared. The whole reason that they don't put the squared over by the x is because it's not the x that's squared, it's this whole expression. And so they've decided that they're going to put it with the sign when we write it in shorthand. All right, so now I have my common denominator here. So I would have 1 minus sine squared x over sine x. This reminds me of something. When I look at that, I'm thinking about my Pythagorean identities. And I've got a Pythagorean identity that says sine squared x plus cosine squared x is equal to 1. How could I use this idea right here to help me simplify that numerator? How could I use that Pythagorean identity?
Change sine x squared to 1. Or
Sine x squared to 1, close. I can't just change the sine x squared to a 1. It's sine x squared plus cosine x squared that gives me a 1. What could I do if I wanted to make a substitution there? thought. What about if I subtracted sine squared x from both sides? Then it would cancel out over here on the left. So I would have cosine squared x equals what? What would I have on the right? Can't combine anything. I'm just going to recopy what I've got. Yes, absolutely correct, Olivia. 1 minus sine squared x. So tell me how I could possibly use that idea here with this numerator. What can I do? Yes, I can take cosine squared x and I can substitute it in the place of that numerator where I've got that subtraction. So now I would have cosine squared x over sine x. Cosine squared x, this right here, that's the same as cosine x times cosine x. So I'm actually going to write it down like that. This is cosine x times cosine x over sine x. I'm almost done with this. Cosine over sine can simplify to what? Cotangent. So this would be cotangent x, and then I still have that cosine x. There we are, fully simplified. Woo, good job with those. All right, I want to look at a couple others where we simplify. And then we're going to start verifying. I think verifying is easier than simplifying, honestly. All right, I'm going to put up 3 more problems that we are going to use as we simplify. Remember, things that I want to keep in mind: the fundamental identities. I've got my Pythagorean identities. We have our reciprocal identities. And then we have our tangent and cotangent identities. We need to move that to the other side. First problem over here, the one farthest on the left. Looking at this numerator here makes me think about some stuff that we did first semester. Like if I had a cubed plus b cubed. That's a sum of cubes, isn't it? How does a sum of cubes factor? You guys remember doing sum of cubes? Sums and differences of cubes? We had a 4-letter acronym to help us remember how to factor a sum and difference of cubes. Yes, Amaya, you're absolutely correct. We had that SOAP acronym. So when we have our sum and difference of cubes, I want the cubed root of my two terms, so A and B. In between on this first factor, it's going to have the same sign. And then I'm going to have a quadratic factor. It's going to have A squared. It's going to have A times B. And it's going to have B squared. So S stood for same. O stands for what? S was same. O was opposite. So that's going to be subtraction. And what does the AP stand for? Always positive. There we go. So that is how a sum of cubes factors. Difference of cubes, same thing, except my signs are going to be different for the first and second one. They're going to be flipped. Can I use that idea to factor that numerator? How can this numerator factor? What do you guys think? The cubed root of sine cubed x so my A value would be sine x, and my B value would be cosine x. So I'm going to follow this same pattern from a sum of cubes. So I would have sine x plus cosine x for same. So there's my first factor. Second factor, my quadratic factor, would be sine squared x plus, now I have to multiply A and B together, sine x cosine x. Oh, is it going to be a plus or a minus in there? This guy right here. Plus or minus? Needs to be a minus there, absolutely. Because remember, it's always the opposite sign there. But then at the end, it's always positive. So cosine squared x all over that denominator. Sine x plus cosine x. Now that I've factored that numerator, do you guys see anything I can do with it that would help me out?
You can cancel the denominator with the first term.
Yes. I can cancel the denominator with the first term. So now I have sine squared x minus sine x cosine x plus cosine squared x. I'm going to rearrange this just a little bit, and I want to know if you guys notice anything when I do that. I'm going to take this plus cosine squared x, and I'm going to move it right here. So I have sine squared x plus cosine squared x minus sine x cos x. Why do you guys think I moved it like that? What did I see that I want you to notice?
Is it one of the Pythagorean identities?
Yes, it is. That is a Pythagorean identity. My Pythagorean identity is sine squared x plus cosine squared x equals what?
One.
Equals 1. So I can take this right here and put it in the place of this whole thing. So I'm going to have 1 minus sine x cos x. Now we are fully simplified. Look in the middle. I see subtraction, I see squareds, I see a lot of numbers going on. What this numerator makes me think of is something like 9 minus w squared or 9 minus x squared. The denominator makes me think of x squared minus 5x plus 6. What can I do with those things? What can I do with 9 minus x squared? Or x squared minus 5x plus 6. What could I do with that? I can factor it. Absolutely. I got a difference of squares up on top. I can factor the bottom. 9 minus x squared would factor how? Nine minus x squared would factor how?
3 plus tan x, 3 minus tan x.
Yes. I can take this guy right here. 3 plus tan x times 3 minus tan x. How can that denominator factor? Think about how I would factor this guy. How would x squared minus 5x plus 6 factor? Yes. With the x's, that would factor to be x minus 2, x minus 3. So I can do the same thing here. Tan x minus 2 tan x minus 3. Can I cancel anything?
Could you cancel the 3 minus tan x and then 10x minus 3?
Almost. I want to. And I think there's going to be a way we can do it. We just got to play with it a little bit. I want to cancel these. But right now, up here, the tan is the thing that's negative. And down here, the 3 is the thing that's negative. I need the same things to be positive and negative. So here's a thought. If I multiply this by -1, would that make the tan negative and the 3 positive?
I think so.
But that fundamentally changes this. But a negative times a negative is a positive, right? So if I do it over there, I would have to also do it over here. Because -1 times -1 just gives me 1, so it won't change it. Okay, so if I do that, just kind of thinking through some ideas here. 3 plus tan x, 3 minus tan x up here. What would I get in this first term right here if I multiply that by -1? What would I get here? If I multiply that first factor, tan x minus 2 times a -1, what's going to happen to both pieces? Yes. I would have -2 plus tan x. Same thing would happen with the other one. I would have negative tan x, or sorry, not -2 plus, I did that wrong. My apologies. The 2 is going to flip to be a positive. I wrote those down backwards. My apologies, guys. The tangent, which was positive, will become a negative. And the 2, which was negative, will become a positive. My bad. 2 was negative, I multiplied it by -1. Tan was positive, I multiplied it by -1. Over here, the tangent's going to switch signs. And the 3 is going to switch signs. And now I can rearrange things. So I would have 3 plus tan x, 3 minus tan x, over 2 minus tan x, 3 minus tan x. Now I can make those 2 cancel. And so fully simplified, I would have 3 plus tan x over 2 minus tan x. Let's look at one more here, and then we're going to start to dig into some verify problems, and we'll keep verifying tomorrow. On this last one that I'm looking at, does it look like I can factor anything? Do we have any squareds that looks like I might be able to factor? No. So if I can't factor anything, I'm going to write everything in sines and cosines. So my numerator would be 2 minus, how can I rewrite tangent in terms of sine and cosine? Sine over cosine. So sine x over cosine x. Down in the denominator, how can I rewrite cosecant x in terms of sine and cosine? One over sine x minus secant x. How can I rewrite secant x in terms of sine and cosine? How can I rewrite secant x in terms of sine and cosine? 1 over cosine. All right here, I can simplify that a little bit. So I would have 2 minus sine x over cos x all over, this would be 2 over sine x minus 1 over cos x. Yeah. Up in the numerator, let's give this thing a common denominator. So I'm going to put this over 1, and I'm going to multiply top and bottom by cos x, so that I can have a common denominator there. So that would make my numerator 2 cosine x minus sine x over cosine x. So there's my numerator. Down on the bottom, let's give that a common denominator too. Multiply this one, sine x, multiply over here, cos x. So then I would have 2 cosine x minus sine x all over cosine x sine x. Ew. How can I stop dealing with a compound fraction here? What would let me be able to stop dealing with a compound fraction? Yes, take out the denominator, flip it around. We're going to multiply by the reciprocal of this denominator. All right, so that numerator, 2 cos x minus sine x over cos x. Reciprocal here is going to be cos x sine x over 2 cos x minus sine x. How does that help me? What can I do now that I couldn't do before? Cross out. What can I cross out? I see a couple things I can cross out.
Two cosine x minus sine x.
2 cosine x minus sine x, that'll cancel. You guys see anything else that'll cancel?
Cosine x.
Cosine x is also going to cancel. So what is this fully simplified then? Just sine x. That whole hot mess simplified to just sine x. Okay. Let's look at a couple of verify problems. I like the verify problems better because with the verify problems, I feel like I've got a goal in mind. With these verify problems, we will always end with left-hand side equals right-hand side. Left-hand side equals right-hand side. That's where we have to end. We are going to transform the left-hand side of these equations until we get the right-hand side. We are not going to touch the right-hand side at all. So I'm going to use some of my simplify tricks, but I know what I'm after. I see this cosine x here. I'm going to leave that be. Or sorry, not cosine x, cosine theta. How could I rewrite secant theta? How can I rewrite secant theta? One over cosine theta. Well, what happens here?
Cross out.
Yeah,
They
my
cancel.
cosines are going to cancel. And so I just end up with 1 equals 1. Left-hand side equals right-hand side. Sweet. Let's see if we can get through one more before the bell. We are not going to touch the right-hand side at all. How can I rewrite secant theta? One over cosine. Hang with me for just a second. That would have sine theta over cosine theta. And what do you guys know about sine theta over cosine theta?
It is tan.
That is tangent theta. And on the other side, this whole time, we had tangent theta. Left-hand side equals right-hand side. Boom. All right, guys. Very, very briefly, I'm going to work on trying to get that unit circle quiz fixed. I apologize. I'm working on it. You guys have a homework that is due for me tomorrow night. That's the night before your quiz. Practicing, verifying, and simplifying. I've tried to scaffold this because I realize it's a brand new skill. You are going to need your Pythagorean identities, your reciprocal identities, and you are going to need your tangent and cotangent identities. Make sure you look back in the note for all those different types of identities. We've talked about tangent and cotangent quite a bit. We've talked about reciprocal quite a bit. We've talked about one of the Pythagorean identities quite a bit. There are two other Pythagorean identities that you should go back and look at and write down. You absolutely should start on the homework tonight. Do not leave this for tomorrow. You probably won't be able to do all of them, but at least get in and look around at it. The more practice you put with these ideas, the better you are going to be prepared for tomorrow. We're going to continue verifying identities tomorrow. And then on Friday, you will have your first quiz of this chapter. I hope you guys have a fantastic rest of your day. Please let me know if you have any questions or if you get stuck on anything, if there's anything that you don't understand how to do. I hope you guys have a good one.